There are many cool elements in Powder Toy. Dust is one of them. You can do a lot of interesting stuff with dust, like set it on fire. Look at it go. It's so pretty when it burns. Truly majestic. Okay, let's speed this up. Now that's done, let's show you some other interesting properties dust has. First off, dust sinks in water and floats in mercury, as shown here. Another interesting thing about dust is that it is blown around by wind more than other powders due to how light it is. You can see this in how the dust is being blown away from the PUMP more than the other powders. Here are some streamers to show the direction of the wind. Now let's get into some stuff you can do with dust. Since dust is flammable, you can heat things up by burning it as a fuel, as demonstrated by this setup. Since this is going to take a bit of time, let's speed the footage up. Another use dust has is as an intermediary between the yeast to firework conversion process, which is carried out by this setup. I will now go through how it works. If you heat yeast, it will start multiplying, but if you overheat the yeast, it will die and turn into dead yeast. If you continue to heat the dead yeast, eventually it will turn into dust, which is how the dust enters the process. If you hit the dust with neutrons, it will turn into fireworks, which will sink below the surface to the bottom. If neutrons hit fireworks, it will cause them to detonate, which is a problem since if the dust layer on the top runs out, the neutrons will start hitting the fireworks and setting them off. Which is why a layer of mercury, which is colored blue, separates the dust from the fireworks in the machine. Dust can float on mercury, and fireworks sink in mercury and dust, so the fireworks will end up on the bottom. So even if the dust layer runs out, the mercury will still be there to block the neutrons from the fireworks. Now I'll show you how the dust is introduced into the neutron chamber. Here I have the displacement system of the machine separated for demonstration. What it does is pushes the fireworks out the chamber on the left and replaces it with the exact same amount of dust from the chamber on the right, so the amount of blocks in the chamber on the left never increases. This is a problem since some of the fireworks can occasionally detonate in the chamber, which decreases the number of blocks permanently. That's why I use this mechanism to add new fireworks to the chamber when that happens. It works by pulling the mercury marked in green, which will in turn drag the fireworks marked in blue into the chamber. The displaced mercury is added back in at the top. The reservoir is being refilled from the output stream down here. More fireworks are added when this sensor detects mercury, and more dust is added when this sensor detects mercury. The reason I have the dust enter the chamber from the bottom and not from the top is because if I drop the dust in from the top, as it falls, it's going to get hit by a neutron, which will turn it into a firework, which is what I wanted to happen. But before it hits the bottom of the chamber and gets buried by the mercury, it will get hit by a second neutron, which will detonate the firework in the chamber, which would be undesirable. Now let's show you how the neutron duplicator works. So the way the neutron gun works is by exploiting the fact that when a neutron passes through glass in Powder Toy, it shoots out photons of the same color at 90-degree angles to it, as shown in the setup here. This game mechanic is supposed to mimic the Cherenkov effect in real life. And when a photon passes through INVS, it turns into a neutron, so you can guess where I'm going with this one. So the way the thing works is it has a neutron bounce into the broken glass, which makes more photons, which the photons bounce up to the INVS to turn into neutrons, which bounce back into the glass, turning into more photons, which make more neutrons, which makes more photons, and a chain reaction starts, which keeps making more and more particles and decreasing my frame rate. In order to deal with this issue, I have made a photon detector. It uses PSCN on top of NSCN, which acts as a photovoltaic cell which creates sparks when hit by photons. So the sparks then cause this piston to extend, which cuts the broken glass off from the INVS, which stops the chain reaction, which reduces the number of photons coming out and hitting the detector. So this timer that is connected to the piston and making it retract will eventually bring the glass back into the chamber, starting up the reaction. And when there is too much photons again, the detector will start extending the piston faster than the timer can retract the piston, cutting off the reaction again. That's how this feedback system stops too many particles from being created. So now let's follow through the machine. It starts up here where the yeast is being multiplied. The yeast then falls down here and then dies and turns into dust because of the heat. The dust then falls down this slope and ends up here, which then it gets pushed into this chamber where it floats to the top and gets hit by neutrons, turning into fireworks and sinking back down again. Then it gets pushed down this slope and arrives at this elevator, which then lifts it up to the top of this pile. The reason the fireworks are only detonating in the pile is because only the pile is hot, the machine isn't. Let's go through some parts of the machine. First off, the reason I have this detached heater here and another detached heater here is to create pressure that will push the dust and yeast down the slope. This demonstration better shows the effect of hot objects creating positive air pressure on dust. As you can see, the dust is repelled by the heater. Since occasional dust blocks escape the previous chamber, this mesh is here to destroy them by sparking them. Because mercury's volume is dependent on its temperature, I have to control the mercury's temperature with these two devices. This one heats up the mercury if it gets too cold, and this one cools down the mercury if it gets too hot. There's also another cooling device up here. What this system here does is stops dust from being overproduced. This A-ray here will trigger the production of more yeast, but it is being blocked by this dust, which stops it from overflowing. So if I remove the dust, it will go through and trigger more yeast to be produced, which will then come down here and block the A-ray, so no more dust will be made and it won't overflow. This thing here is a detector that will stop the machine when too many fireworks have been made. The way it works is it will push this timer off this A-ray when it detects fireworks, and this timer is what's triggering the elevator, so when it's disconnected it will stop working. When you remove the fireworks, it will slowly start retracting back into position and start triggering the timer again. Okay, as you can see, it did it. The reason stopping the elevator stops the machine is because a backlog of fireworks will build up, which will block this thing, and no more dust will be able to be pushed because these pistons will be over their push limit. So with all of that out of the way, let's show you some other odds and ends about dust. First off, dust has an alternative pathway to make it, where you can hit gunpowder with neutrons to make dust instead. Because of the neutrons, the dust will immediately turn into fireworks. This isn't particularly useful since there isn't any way to make infinite gunpowder without using duplicator blocks or spawning it in. Dust is also the element selected by default in Powder Toy. Along with that, it is also selected by default for the stick figures. And on that note, this is the end of the video. Goodbye for now, or perhaps forever.